All right, so with our graphing, when A is greater than 0, we talked about this one yesterday, you guys. A is greater than 0 is when we go and look at that parent, which we have here in the middle in blue. And I was just saying in class, it's hard for them in class to see my color, but on the video I can tell it's showing up better. The parent's in blue. We talked about a vertical shrink, and it seems really weird that when it got wider, we called it a vertical shrink. But the reason we call it a vertical shrink is because it's in consideration of where it's at with, okay, so it gets wider. The vertical shrink is because as it gets wider, this parent function is pulling down towards the x-axis. Parabola is pulled towards the x-axis. And so from blue to red, it's like it went and got pulled down towards x. We didn't write anything for a vertical stretch. We should have. Vertical stretch is when it gets, the parabola is pulled away from the x-axis. Parabola is pulled away from the x-axis. We're going to look back at this over and over and over again to get a handle on that. How do we talk about a vertical shrink versus a vertical stretch? Morning, Coach. How do we talk about a vertical shrink versus a vertical stretch? Yep. Now, this is our positive A values. Our parabola is all opening up. Down here, we're going to start talking about negatives, and we're going to start talking about negatives in two different ways. I'm going to pick up my blue, and I'm going to go and find my parent, which is the middle parabola here. In blue again, I'm putting my parent. F of x equals x squared is my parent. And then we'll look at changes that are made through here. Bless you. If anyone at any time decides you are not close enough to see, bring yourself up to one of these desks. If you are not close enough to see, move yourself up here. So my parent's sitting in the middle. And then in our investigation, we talked about this crowd right here. And I'm going to switch over to, red. These are our values that are fractions in between, fractions and decimals in between 0 and 1. Now, when I talk about these as fractions and decimals, I'm just saying fractions and decimals that are between 0 and 1, we can still have, like, up here, a value greater than 1. We could have A is 2.5, and it's still going to be a vertical stretch. But when I talk about this crowd, it's like we're 0.000000, and then to the left of it on a number line to like negative 0.999999999, not quite 1. All right, so just that chunk. Think of that chunk as like you owe me $1 or less. You're in the hole $1 or less, pennies. Okay. Now they talk about this one again as being a vertical shrink. Vertical shrink is when the parabola is pulled towards the x-axis. You guys see how that's happening here? From parent, as it gets fatter down there, it's going towards the x-axis. The sides of the parabola are going up towards the x. This is our negative fractions and decimals. Negative fractions and dec. Again, like you owe me between a penny and 99 cents, you're in the hole, negative. Vertical shrink. And then when we start talking about numbers that are less than -1 in this crowd, it's going to go and get skinnier. So you owe me more than $1. Think about it as in the hole, negative. When you are dealing with a negative f of x equals -6x squared. That's going to be a vertical stretch, which means that the parabola is pulled away from the x-axis. It's getting skinnier. So everything we're talking about is how it is compared to this line. Vertical stretch, vertical shrink. Vertical shrink, I'm going to write it again. Towards x-axis. Vertical stretch, I'm going to write it again. Away from x-axis. Towards x-axis, away from the x-axis. In the notes section here, I'm going to write this. Look back over and over to these notes. Over and over again until you remember. And I will look back over and over again until I remember. Look back over and over again until you remember. Let's see how this is going to work out. Before we go to the extra practice, what I would like to show you guys is from our Big Ideas website, and I'm going to pick up my phone here in a second and change this so it's in the video too. But from my Big Ideas website, hold on. All right, so from my Big Ideas website, I've got a short little video so you can hear this. I love it. I call him the textbook computer guy because it doesn't really sound like it sounds like a computer man. So what I'm going to show you, there we go, that works, is how questions like these that we're looking at in extra practice 1 and 2 are meant to be answered.
From the graph, you can see that the vertex is 2, -4, and the axis of symmetry is x equals 2. The function is decreasing when x is less than 2, and the function is increasing when x is greater than 2. The domain is all real numbers. The range is all real numbers greater than or equal to -4. When x is less than 2, y increases as x decreases, and when x is greater than 2, y increases as x increases.
All right, so what different things just went into that? We go back over here, and I'm looking at it on my screen, so I'll help remind you. We're going to go down here. Take a look at number 1. Put a point where you see the vertex. And I'm going to add a little question here on number 1 extra practice. What color? I don't care. Yellow? Let's go yellow for vertex. Just highlight it. Let's put the vertex on number 2 as well. Cool? Put the vertex on number 2 as well. What's the coordinates of our vertex? I'm going to pick up my pencil now and write those down. Where's our vertex at for number 1? -1 and? Perfect. Now, we know the vertex is at -1 and 1. What does that tell us about the axis of symmetry? Axis of symmetry, x equals, it doesn't look like an x, that -1. Perfect. Let's sketch it in. I don't know if you have a ruler, but let's just go and make like a, I'm going to use my yellow actually. I'm just going to make kind of a dashed line to show that axis of symmetry. Just a dashed line to show the axis of symmetry. Now, like on our other page, we can, and I'm just using a pencil for this, like on our other page, the notes we had on the first page, as x approaches 0, the parabola is decreasing. As x approaches 0, the parabola is decreasing. I just wrote in pencil. And I picked up my pencil now. The only color I'm putting on here is that yellow. And as x moves away from 0, the parabola is increasing. Now, the next part that they talked about was the domain and range. I remember addressing the domain and range with my Algebra 2 kids. Does that come out of my mouth in front of you guys? The domain of this function. Let's write it down and I'll tell you how we figure out what the domain is. The domain is the x values that can go into this function and have a y. The x values that will work for the function. Now, this is kind of a broad idea. And it's a little abstract. It's a little bit abstract. Would there be any reason that you could think of that I could like if I put in, let's say 10, the value of 10 is not on this x-axis. Could I put 10 in to the equation for this function, you think, and get a y value to go with it? Doesn't this kind of show that it's going to keep going up? So if this is going to keep going up, I would assume that as I keep moving away with x's, that I could put any of these x values in. It would just be a much higher place on the graph where the y value was. And same over here. I could go and put any x value in as I go in the negative direction, maybe even like negative 50, and there would still be a place up on the parabola way up high that there's a y value that goes with negative 50. And so that means for x, the domain, x can be all real numbers. X can be all, and actually I'm going to show you guys some notation. This means real numbers. It's a capital R with kind of a double bar on it, and that means real numbers. Say it again. Nice. Ms. Gerchek taught you. Good. X can be all real numbers. That's the domain. I'm going to put a little colon here. Now, range. If domain is x values that work for the function, what do you think range is? Y values that work for the function. Now, in the case of this parabola, that vertex is actually a minimum, isn't it? It's the smallest place, the smallest point that this vertex goes down to. What's the lowest y value it's hitting on? The lowest y value it hits. It's 1. Are we going to ever have any y values for this parabola where y is 0? No. Where y is negative? No. Can y be 1? Yes. Yeah, it is at the vertex. Range is y is greater than or equal to 1. Dominic.
What is that word under range?
Y values that work.
Okay.
The y values that work. So going along with what we saw in the video, we addressed where is its vertex, where is its axis of symmetry, got that from the vertex. We talked about how it's decreasing as x approaches 0. The parabola is increasing as x moves away from 0. And domain, all the real numbers, range, we're never going to go below -1 for y. So let's go over to number 2 now. I'm going to look to you guys to give me some information here. I'm just going to write this up top because that's where the vertex is. Write it down on your page. What are the coordinates of that vertex? Write it on your page. Let me just throw stuff all over. So what do you have? Say it loud. Positive 3 and 4. That can take me then to axis of symmetry. Start anticipating what I'm going to be doing next. X equals what? There you go. Grab it right from there. Let's take our yellow marker, yellow pencil, and put that axis of symmetry there. We could fold it right in half along that axis of symmetry, and we'd have mirror images. What next? Not quite. I drew some stuff on my graph. So approaching, actually I got to talk about this as it's approaching x is 3. This is increasing as x approaches 3. Increasing as x approaches 3. Now, I'm talking about it as x approaches 3 because that's the point where all of a sudden it starts going down. And then I come over here and say it's decreasing as x gets bigger than 3. And in all honesty, over on this first one, Shouldn't I have been talking about how it approached -1? It was decreasing as x approaches -1. As x approaches -1. Increasing as x gets bigger than -1. So this whole idea of identifying characteristics, holy cannolis. We got what? Vertex, axis of symmetry, increasing, decreasing, how it's acting. So 4 things. And now we'll move on to the 5th and 6th domain. What do you think about this one? Is there any x values you think we're going to be limited to? Most of these, I'm going to tell you guys, when we're not in the context of some specific problem, your x values are probably going to be all real numbers. I could go on to any larger positive number, plug it in, there'll be a y value way down low on the parabola. I can go to any smaller negative number, plug it in, there's going to be a y value way down on the parabola. X can be all real numbers. That nice capital R with the double bar. Now the range matters a lot more because it has to do with our maximum, doesn't it? What's the highest y value this parabola is going to take on? So y, wait a minute, so it's the highest one. So how do we need to write that then? Less than or equal to 4. There we go. Y is less than or equal to 4. All right, I think good time to take a pause.